Hi, everybody. Warm welcome. Uh, so, perhaps before I begin, I should just make a short introduction. So, as Maya mentioned, I look after business development, particularly within the DACH region for KX Systems. And primarily what I'm involved with is moving the technology into other verticals outside of our core business over the last 25 years, which has been finance primarily. And being on the stand yesterday, we just have a team up here on the next floor. The questions that we were getting mostly were, what do you guys do? What is your development within the Internet of Things, and why are you moving into the Internet of Things when your core competence is within the finance business? Well, the reality is we've already moved into the Internet of Things, and really what the premise of today's talk really is just to outline some of our capabilities and the lessons that we've learned within the finance industry over the last couple of decades and how we're adapting those learnings to solve challenges within the Internet of Things. And this is really driven by the growing volumes of data that we're seeing within those other areas. So perhaps even before I begin, I could ask, has anybody here heard of KDB Plus before? We've got a couple. That's positive. Good. Good. Well, look, a talk that I heard the tail end of yesterday was primarily around autonomous vehicles and some ominous use cases for autonomous vehicles in military applications. And it got me thinking actually about some of the developments within high-frequency trading over the last 20 years. So trading has primarily came from being a manual process to being an automated process. And with that automation comes some difficulties with compliance when you're having robots and algorithms that are driving trading patterns. So, what I'll do is I'll just take you through a presentation, just outline who we are and what we do. So, First Derivatives is a publicly listed company, and First Derivatives are the parent company of KX Systems. And we've been providing financial software consulting to the majority of the world's banks for the last number of decades. KX is the technology line of this business. Primarily, the core business has been within banking, regulators, exchanges, but more recently we've started to advance into other verticals, so those that are driven by data-intensive use cases like telecommunications, utilities, life sciences. And really what the company is known for is the ability to handle very fast, low latency, high frequency data that's coming in very extreme environments, normally mission critical environments, as you can imagine, within Wall Street where cash is king, essentially, and microseconds can mean millions of dollars. So the company itself, without boring you with too much marketing information, it's over 1,800 employees at the moment, and we've 14 offices. But as you can tell from my accent, we're based in Ireland. So we're from a city called Newry, which straddles the border between Northern Ireland and the Republic of Ireland, which is quite interesting with all the political climate that's developing at the moment. But our business is global, and you'll learn a little bit more about what we do. So IoT and the lessons learned from Wall Street is really where I want to go to with this, and just allow you to sort of gain some outline of what we do. The guys upstairs will be available for a 2-hour Ask Anything session after the talk. So some of our customers, just to give you an outline, so the top 20 of the world's tier 1 banks all use our technology, and this is mostly for data capture, analytics type use cases. So we often boast, I don't know if it's a boast or not, but if we turned off our software licenses tomorrow, Wall Street would essentially stop working. So that's how saturated our software is within Wall Street. Within Germany, you can see on the board, we work with Deutsche Bank, Commerzbank, DECA Bank, but essentially name a bank and we work with them. But more interestingly, one of the use cases that you can see on the slide deck, which is quite interesting, is that we work with regulators. So regulators that are trying to maintain the integrity of the stock market. So the United States regulator and the Australian regulator, we provide them software to police the market. So essentially, we were providing software for high-frequency traders to try and almost beat the market, and now we're helping them surveil or police the market as well on behalf of governments. So you can see some research institutions as well. So we do have free academic licenses, and we do work on research projects in tandem with some of the great, the great academic institutions as well. So too much data, I don't need to tell you guys that. So data is everywhere. It cannot be stored in traditional relational databases, and that's the premise of what we do. So we have been solving big data challenges in finance for a number of years, or decades, as we said previously. And with the emergence of IoT, growing data volumes, enormous growth within the sensor technology and the amount of sensors and the frequency that these sensors are emitting data at, we have found that other industries are actually coming to us to find out what lessons we have learned within finance in handling high-frequency data. So that was what we were founded on, was that inability of traditional database technology to keep up with these ever-growing volumes of data. So batch processes are no longer sufficient. So this is the trading floor of the New York Stock Exchange back in the 90s. And when you think of a trading floor, this is probably the culture that you would imagine. So you think of the hustle and bustle, people waving tickets around to buy and sell, a physical location, people staring at screens, and a lot of aggressive behavior from the guys on the floor looking to make the latest trade. And in this environment, it was called open outcry, so jostling at a central screen to get your trade. And in this world, before the emergence of high-frequency trading, a trade might have taken 12 seconds. So between you making an order and the trade coming through, that process could have taken 12 seconds. So the human element was very much at the heart of this process. And what I'm trying to relate back is the relationship between the development of trading and trading technology from the human element to the machine or the computer, and relating that back to the Internet of Things. So in years or decades gone by, the human was the only element involved in communicating with the Internet. But in today's world, we know with the Internet of Things and devices connecting to other devices now, there's more and more machine element and autonomous element involved in that. So the electronic markets. So with the rise of the machine and autonomous trading, the open outcry is dead. So there's nobody waving tickets anymore within the trading rooms of the New York Stock Exchange. This is it in the, after the millennium. And this was driven by the inability of humans to place trades fast enough or automatically without making errors. So if you think of the rise of the machine, it's all about beating the opposition. So if we're all brokers in a marketplace, we want to make that trade faster than everybody else. And there was a very famous book called The Flash Boys by Michael Lewis, and that really outlined how high-frequency trading companies were using all sorts of techniques to try and get their trade to the exchange before the next broker, so effectively to play the market. And ironically, this was all about technology and all about speed of processing data. And it was also right back down to the wire. So the actual wires that were taking the messages from the high-frequency trader to the exchange itself where the trade would take place. From memory, I think something like 1 yard was worth a nanosecond of cable going underneath the ground. So there was a race for traders to actually get their server closer to the exchange itself so they could beat the person behind. So the high-frequency trader that was driven by technology was actually using the technology to beat myself or the normal everyday trader that might want to use and dabble with their computer at home. They were effectively making the trade before my trade reached the exchange through technology and through speed and low latency type technology. So this has worked to a certain extent up until 2010. There was a very famous incident. There was a flash crash, as it became known, and the flash crash was when a faulty algorithm actually penetrated the marketplace and caused the stock market in the United States to drop 1,000 points in 5 seconds. So this really highlights the damage that an algorithm can do or the automated process can have on the stability of financial markets. So the chap that was speaking yesterday, he had pictures of tanks and he had pictures of drones that were like driven autonomously and controlled autonomously. An algorithm within a very high frequency extreme environment can do a lot more damage probably than an autonomous tank. So something as simple as a faulty piece of code could bring down the financial markets, and the markets actually shut down after 5 seconds. So what we're in the middle of is an arms race. We're in an arms race where banks, brokers, hedge funds are all trying to beat the market to make the trade faster. And this is really just to highlight where we came from. So KX came from this essentially arms race of technology, trying to get there faster, making your database more efficient, making the real-time and streaming data capture more not only efficient, stable, and also very extremely low latency. So we can talk a little bit more about that, but in this environment, big and fast data is king, and real-time in this environment is nanoseconds. So electronic markets again, you can see the growth pattern here in the graph. This graph represents traded trades on the US equity and options market, and you can see there the graph peaks at 18 billion options quotes per day, and this is the sort of volume that a hedge fund or a bank are capturing within their database. So we've been helping firms react quicker than the opposition for over 20 years, and this is a very extreme environment, and I just wanted to highlight that just to let you know where we came from. So I mentioned previously, in the old days, a trade could take 12 seconds to complete through that process. In today's world, you can complete 1,000 trades or transactions within a second. So KDB Plus, at its core, is a column-based time series database with an inbuilt programming language which is called Q. And our roots are in the APL programming languages, which have been around for 50 plus years. So fundamentally, at its core, and I really am just doing this to highlight the sort of technology that we've been using within these marketplaces, because this is standard within the banking space and the financial services space. So it sounds very salesy for me to say this, but it is the world's fastest time series database, and it's been proven to be so by independent bodies such as Stack, which is the key financial independent benchmarker of financial databases. And we not only hold these records for low memory usage, but also for speed. So we hold 15 out of 17 gold medals in those benchmarks. There's also some independent benchmarks which put us 15,000 times faster than Spark, for example, in some particular scenarios. So at its core, and this is really where technology we think is going, at its core what we have is a streaming real-time and historical data capability within one platform. So other technologies might have a real-time engine. Other people might have a time series data store. We have all of these capabilities and elements in one platform, and that allows us to be tremendously scalable in what we can offer. So we have clients that are using our software on Raspberry Pi because it's got extremely small memory footprint, and we've got people that are using the software in 20,000 core Amazon deployments. It can run on commodity hardware, it can run on cloud or edge devices, but fundamentally the programming language is very expressive. It's a derivative of SQL, and that's at the heart of what we do, because there's no latency between the programming language and the data itself. It's integrated, so you don't have to pull data out in SQL and run your statistical analysis in R. You can do everything in the one platform. So it's multi-core, multi-processor, and multi-server. And it's also got an inbuilt complex event processor for things like multivariate analysis as well. So I think I've covered some of these points. In terms of the high precision timestamps, we have timestamps that are monthly, weekly, daily, per second, per millisecond, and right down to the nanosecond in terms of the granularity, which is very important within Internet of Things, because we know that within the Internet of Things, at its heart, all of the data, or virtually a lot of the data that's coming from sensors, is time series. So what we do is time series at its heart, and all of our data points that we collect are time-stamped, because time tables are a first-class object within the KDB Plus database. So what we like to think we offer is the ability to give our clients all of their data. So a lot of the customers, for example, that we're talking to within the IoT space are saying to us, well, look, we've got millions of sensors that we're pulling data from at high frequency, at X hertz rate. And we just can't see all of the sensors to get all of the insight because we can only narrow down our process control to 5%. So we've got a 5% view of our best known sensors. With the emergence of machine learning and these sorts of techniques, we're able to come into these clients and say, look, you don't need to aggregate your data with this technology. You can receive and collect, process, analyze all of your data in one platform to get all of your insights and all of your wisdom. So why is it the fastest? So we have a close relationship with Intel, and we work with Intel very closely on testing their latest hardware. So you can see all of those marketing materials online through the Intel website, but we take advantage of the hardware, and that's something that we do slightly differently from some other software providers. We think it's very important to scale and look at the integration of the software right down to the instruction sets on the chip itself. So our technology, as you can see here, exploits L1 CPU caches, and it's also, as I mentioned before, extremely small in terms of its hardware footprint. So you can see here, 500 KB is the size of the core executable of our platform. And what we can do is we can send that to you via email, and you can actually load it up on your home computer. So it's extremely lightweight in terms of what it can provide. So in terms of the programming language, it's very straightforward. It's an SQL-like syntax. So anybody with SQL experience can load up KDB Plus and use Q and get to grips with it, usually within a few weeks. You can use SQL queries through KDB Plus, but we've developed a language called QSQL, which allows you to use a lot of your SQL-like queries. But you can see here, it's a much cleaner, much more concise, simple programming language than SQL. So the designer and founder of KX Systems, Arthur Whitney, he actually looked at SQL and some of the coding and said, look at this line, for example. Why do I need to have color in this line 3 times? So he trimmed it right back and put color in there once. So we find that with developers, this simplicity can make them 5 to 10 times more productive in the development work that they want to do. Some performance snippets. I'll not bore you with those. The slides will be available after the talk. But in terms of streaming data coming into the platform, on one core of KDB Plus, you can process and analyze 4.5 million records per second per core. So on one core, it gets a lot of value, and you can see how it can offer a reduced sort of hardware footprint and advanced performance at very low scale. You can see, I referred to this client previously, but the New York Stock Exchange is one of our clients, and they've accumulated 10 trillion data points and over within our database, and we actually were handling petabyte databases since the 90s. We also offer some data management tools, so it's not just the core database that we offer. We also have various deployment models and frameworks that we can use for data capture, analytics. You can create application development environments on top of KDB Plus if you want business users to have access to the power of the programming language. So what can we help people achieve? So we can help them react to high-velocity streaming financial data, millions of updates per second. And we can help them aggregate this data to give them a real-time view of the world that we live in. And primarily, we do time series data, but we don't care really what the data type is, as long as it's structured or semi-structured. That's all we care about. And some of the use cases that we've adapted the time series analysis to is multivariate analysis in real time, which at its core is what we specialize in. So taking streaming data from sources, it doesn't matter again what the source is. It could be a sensor, it could be some sort of CSV file if it's a batch. But we can take this data in, and we can compare real-time data with historical data to provide you various use cases and applications, such as anomaly detection, predictive maintenance, and various other multivariate type use cases. So once we can store, capture, and analyze the data, we can make sense of it. So that's a bit self-evident to say that. But in order for firms to be predictive, they need to be truly reactive first, and they need to get access to all of their data. So, Internet of Things, we've all heard the buzz terms, the buzzwords, but like trading, and this is one thing I wanted to highlight at the start of the talk, like trading, people are no longer the key communicators or actors in communicating with the Internet. Machines are now the actors, so things, as we like to call them. And with the emergence and development within sensor technology, higher frequency sensors, we find that things speaking to things, various other connected devices spewing out massive amounts of data have left us with questions that we can answer. So people say to me all the time, like, why haven't I heard of KX before? And I answered the question several times yesterday, and the answer is that other industries weren't dealing or having to deal with the challenges of the scale of data that we manage until now. So people are starting to look to us. So for decades, we've been handling billions of records per day, trillions of records in a historical database, and now some use cases we're finding that we're starting to pick up some of those questions and respond to them. So you all know the sort of metrics around Internet of Things. So 1 zettabyte by 2020, 26 billion devices will create 20 zettabytes of data per year. I'm told 1 zettabyte is 1 billion terabytes and 1 trillion gigabytes. I'm sure a lot of you here know that. And the KX solution meets that by able to process data from any source, pull it into our platform, run complex event processing against historical data, and present the insights back to you how you would like to see it. So we have a Lambda architecture, as I mentioned before, real-time historical streaming in one, and it's in one architecture, and it's clean, it's simple. You don't need 50 or 60 different elements that you might need in a Hadoop-type database or instance where you have a Frankenstein, essentially, different pieces of patchwork to produce the results that you want to produce. So, KX, I'll not take you into any deeper, more technical slides. I have some architecture slides to follow. How long have I got? Man, I'm finished. Oh, and I speak so fast. I speak so fast, too. OK. Well, thanks very much, everybody. We are available for the 2-hour session upstairs. Feel free to call up, and we can show you some architecture diagrams as well and some more technical slides. I'm done. Thank you.